My name is Jessica Fay and this is my Assignment 17 presentation, Chemical Bonding and Structure. Polarity. So polarity in a molecule happens when one of the atoms within the molecule is more electronegative than the other, making one end of the molecule more positive and the other being more negative. And now the molecule effectively has two poles. It happens because the distribution of electrons between two or more atoms isn't even. One nucleus has more pulling power on the electrons than the other atom's nuclei or nucleus. When the electronegativity difference is more than 0.4 and up to 1.7, the molecule is likely to have polar covalent bonds. We can identify the electronegativity of each atom from the periodic table, shown here in figure 1. A quick subtraction can help us to find the electronegativity difference between the atoms. The larger atom in a molecule will have a larger, more positive nucleus and therefore will have more pulling power and be able to attract more pulling power of the electrons, attract the electrons more strongly, resulting in this atom of the molecule being slightly negative overall. And this is shown in figure 2 in this water molecule. You can see in the water molecule here, the larger atom of oxygen is the electron-rich region, and the smaller hydrogen atoms are electro-deficient regions of the molecule. Dipole moments. So this is a vector quantity, means it has both magnitude and direction. It's represented by the arrow here pointing in the direction of the movement of electrons. A dipole moment is the result of charge separation, explains route, and they occur in both covalent and ionically bonded molecules. Dipole moment is written as the Greek symbol here, mu, and is measured in debye units, and is equal to the separated charge times by the distance between the atoms. Predict the intermolecular forces of water. So I predict that water will have van der Waals forces here, and that is because they occur between all molecules and atoms due to the constant movement of the electron cloud, and therefore short-lived electrostatic attraction occurs. Even though they're quite weak intermolecular bonds, they do help the substance to have a higher boiling point. Electrostatic attraction is when the more negative oxygen atoms of one molecule of water will be attracted to the more positive hydrogen atoms of a neighbouring water molecule. Dipole moments here. I predict those are in H2O because they occur between molecules that have permanent dipoles, such as water, again where the larger atom has more pulling power over the electrons due to its larger positive nucleus and gains a slightly negative charge. I predict hydrogen bonds as well because these are in molecules that contain hydrogen atoms. These are especially strong because of how close their small hydrogen atoms can get to the larger, more negative atom. And finally then, consequences of hydrogen bonds in water can lead to high specific heat capacity. So it takes a great deal of energy to heat all cool water, therefore is vital for the regulation of temperature of our planet. The surface tension. Hydrogen bonds result in cohesion forces, which explains why water molecules attach together, like for example in a rain droplet on a surface, rather than spreading out completely. The density is very important, so ice is less dense than water, so water is more dense, resulting in ice being able to float on top of the water, and therefore the whole body of water of, say, a lake or the ocean doesn't freeze, which would obviously be detrimental to lots of sea life. The high melting and boiling point. It takes a huge amount of energy to break hydrogen bonds. And this is why water is a liquid at room temperature, and which is very important for life as it's used as a transport medium within blood vessels. And adhesion. So adhesion properties, water molecules can attach to the sides of things and travel. This is vital for life as water can stick to the sides of xylem cells and travel up plants and be supplied to the whole plant from the root. And this is all of my references, and thank you very much for listening.